morning friends. Today we are going to continue with the same chapter, that is chapter number 2. In the previous lecture we studied about the zeros of a polynomial and how to find out the zeros of a polynomial, how to find out the coefficients of any of the variables asked, and we practice some of the examples. Now in today's lecture we are going to start with the next topic, that is the remainder theorem. Remainder theorem. As the name suggests, remainder can be obtained when we divide two numbers, right? When we divide two numbers, then we can find out the remainder of any of that division. Suppose, let me say for example, as we studied in the previous classes, if I say that 63 is divided by 9, that is for me the first example. Then second example, if I say that 84 is divided by 3, right? I am having these two examples right now for me. So if I go on dividing 63 by 9, then that is 9 into 7, 63 will give me a remainder 0 after the subtraction. And for the second one, if I say that 84 is divided by 3, then that will be 3 into 2, 6, remainder 2 here, 4, and 3 into 8, 4, right? So in these both examples, if you clearly see that when I divide 63 by 9, I get a remainder 0 here, and when I divide 84 by 3, I get a remainder 0 here, right? So for these cases the numbers are perfectly divisible. If I take for example that is 105 divided by 2, right? So what is the thing happening here is 105 when divided by 2, that gives me 2 into 5, 10, subtraction is 0, and this 5 will be brought down, carried down here, so that becomes 2 into 2, 4, with a remainder 1, or with 1 as the remaining number. Let me say for example, if I say that is 138 to be divided by 5. Now again I am performing here, that is 138 divided by 5, so that is 5 into 2, 10, subtraction here is 3, this 8 will be brought down here, so this 7 into 5, 35, and the remainder is again 3. So friends, see that in the first and second cases we had the division that is perfectly divisible. That means if the remainder is 0, then the numbers are perfectly divisible. It means like that, right? Perfectly divisible, that means the second number divides the first number keeping a remainder 0. That is known as perfectly divisible, means remainder is 0. So in these kind of examples the remainder is 0, whereas in third and fourth example you can say that there are some numbers at the end of the division. That means we are getting some remainders present which are a non-zero number. Non-zero number, that means they are not 0. They are known as non-zero numbers. So these numbers are non-zero. That means for the second one the remainder is 1, and for the third one the remainder is 3. Right? Now can you see that how this 138 can be written in the form of that division? So can I write it like 138 is equals to 5 into 27 plus 3. Check it friends. This 138 can be written as 5 into 27 plus 3. Yes or no? Check. 5 into 27, that is 135, plus 3, that is 138. Yes or no? Okay. Now coming back to this division again, I am taking that the last example. What is 138 known as? This 138 is known as the dividend. Yes or no? Right? As we studied in the lower standards, that the number that is divided, The number that is divided is known as dividend. What is this 5 known as? That is divisor. The number that is dividing, right? The number which is dividing or number that is dividing is known as the divisor. Then the number that we obtain on the dividend, that is known as the quotient, and the number remaining at the last is known as the remainder. Yes or no? So what can you say about this now? Here 138, that means dividend is equals to divisor into quotient plus remainder. So from this result I can say that dividend is equals to divisor into quotient plus remainder. Yes or no? So that is how the basic division goes here, right? Dividend is equals to divisor into quotient plus remainder. Now these are all the numbers, but here in this chapter we are talking about the polynomials, right? We are talking about the polynomials. So when it comes to a polynomials, in the same way that you divide the numbers, we can also divide some polynomials. Yes or no? Now here if you see that here in all of the cases the divisor was always less than the dividend. Yes or no? See, this is the dividend 63, the divisor is 10, obviously it is less than 63. In the second case 84 divided by 3, that means the divisor 3 is less than the dividend 84. The third one 105 and 2, so dividend 105 is greater than the divisor 2, or divisor 2 is less than the dividend 105. And in the fourth case, that is 138 divided by 5. So in all of the 4 cases we had the divisor less than the dividend, right? So in the same way now, if I say that, for example, if I am having here how to divide 2 polynomials, right? How to divide 2 polynomials. I am writing one example here, that is p of x is equals to the first of the example, p of x is equals to x plus 3x square plus 1. Sorry, it is minus 1. My mistake, it is minus 1 to be divided by g of x is equals to 1 plus x. Right? So this is the example that I am having, that is divide p of x by g of x. That means divide the first polynomial by the second polynomial. How to perform this division? How to perform this division? So to perform this division, first of all you shall check that step number 1, check whether the terms in both polynomials are in descending order of their powers. Check whether check whether the terms in both the polynomials are in descending order of their powers. If not, make them in the descending order of their powers. Right? So I am going to perform it here in the next thing. That for the given polynomials, the first step here will be p of x, that is equals to 3x square plus x minus 1, and g of x is equals to x plus 1. Note that friends, in both the polynomials now we are having the powers of the variables in the descending order, right? Check whether the terms in both the polynomials are in descending order of their power. Descending order, that means in the decreasing order of their powers. So see, first of all, here the power of the first term x is 1. Here the power of the second term 3x square is 2, and here it is 0. So first of all we need to arrange that as 2 1 0. So we have arranged 3x square plus x minus 1, and the second one is 1 plus x. So g of x is equals to 1 plus x. So we shall now make it as x plus 1. Okay friends, so this first step is completed here, right? After completing the first step we shall now divide it. So the second step is divide p of x by g of x. That means how to divide them, as we have written in the first case, that means the division of the numbers. The dividend, this will be now acting as the dividend. So this p of x here is the dividend, and g of x here will be the divisor, right? So if I write down here, that is 3x square plus x minus 1 to be divided by x plus 1, right? This, let me write down again. Three x square plus x minus 1 to be divided by x plus 1. Now how to perform the division here? Note that friends, here we shall look for the first terms of both the divisor and the dividend polynomials. Now see, here I have written only the dividend and the divisor, but note that friends, this dividend here in this example is actually a polynomial, so we cannot simply write it down as dividend. That will be a dividend polynomial, and that will be a divisor polynomial, right? Because this are here a polynomials, both of them are polynomials here, so we cannot simply write it down as the dividend dividend or divisor. Both of them must be written as the dividend polynomial and divisor polynomial. So that is about the dividend polynomial and divisor polynomial. We have written in the format here. Now we shall perform. So the third step here would be step number 3. Check or make the first terms of both polynomials. Which both polynomials? This both means the divisor and the dividend polynomial. Make the first terms of both the polynomials as same. How to make them same? So I have written that make the first terms of both the polynomials as same, but how to make them same is again a question. Now friends, we shall look for the term that is a smaller one than the other. So here it is x plus 1, here it is 3x square, right? Here it is x plus 1 and here it is 3x square. Now see friends, we cannot make 3x square to x, because that is, we cannot decrease the power of any variable here, but we can increase them. How? How to increase them is, we shall simply multiply them by the remaining thing. That means how to make this x as 3x square is basically, first of all, 3x square, that is of the dividend polynomial, x, that is of the divisor polynomial. You can cancel out the common terms here. So how to cancel out this common term? What is 3x square? That is equals to 3 into x divided by x. 3x square, x square, that means x into x, right? And 3x square, that means 3 into x into x. Okay, So divided by x, that gives me x and x cancelled, and that is equals to 3x. In this way you can find out the difference of both the terms. In this way you can find out the difference of both the terms. The difference means what is to be multiplied to the divisor polynomial such that the terms or the first terms of both the polynomials becomes same. So this is the difference here, 3x. Now if I multiply this by 3x, then that will be here 3x. 3x into x, that is 3x square. 3x into plus 1, that is plus 3x. Now we shall perform the division here as we performed in the division of two numbers. Division of two numbers, that means simply dividing the second one from the first one and writing down the difference. So 3x square minus 3x square can be cancelled and written here 0. X minus 3x. Now friends, you shall look for the new sign, because after subtracting, this minus is now acting as this plus. So plus x minus 3x, that is minus 2x, right? And this minus 1 is to be brought down as we did in the division of numbers. See friends, the division here, the process of the division is very easy because it is being already repeated from the division of numbers. The new thing that is how to find out the difference of that both the polynomials and simply how to multiply them. Now again we shall check here. Here it is x, here it is minus 2x. So this will act as our dividend polynomial. This is our divisor polynomial fixed. So again we shall take minus 2x, and to be divided by the divisor polynomial or first term of the divisor polynomial. So you can simply cancel out x and x, and that is minus 2, right? So again multiplying by that difference, minus 2. Minus 2 into x, that is minus 2x. Minus 2 into 1, that is minus 2. Now see friends, here we are going to subtract, but subtraction simply means change of sign, right? In division of polynomials, subtraction means change of sign. So that means elimination or subtraction, both the things are same. Subtraction simply means change of sign. Now this minus here was changed to plus. See friends, here both the terms has plus. Here there was no sign, but that was plus here. That plus is being now changed to minus. Here this is minus, so this minus will be changed to plus. So that now we shall look for the new signs. Minus 2x plus 2x, that will become 0. Minus 1 plus 2, that will become 1. Right? Yes or no? Okay. Now we shall simply write down in the format that I have written over here at the bottom. That means dividend equals to divisor into quotient plus remainder. Okay. So what is our dividend here? Therefore 3x square plus x minus 1 is equals to divisor, that is x plus 1, into quotient, that is 3x minus 2 plus 1, right? So that was about the basic division. So we got dividend polynomial equals to divisor polynomial into quotient polynomial plus remainder polynomial. You can check it out by multiplying, that is x into 3x, 3x square, x into minus 2, that is minus 2x, plus 3x, that is minus 2, and again at the last we have plus 1, so that will become minus 1. So that is about the division of this polynomial p of x by g of x in the form of this dividend equals to divisor into quotient plus remainder. Note, very important thing, that see friends, here all these terms, dividend, divisor, quotient and remainder, are all four polynomials. Yes or no? See, dividend is a quadratic polynomial, divisor is a linear polynomial, quotient is again a linear polynomial, and remainder is a constant or a zero polynomial. So the main thing that lies in this division here is that we can divide the polynomials also such that we divide the numbers, but in a format that we have written here in the steps. Make the first terms of both the polynomials same and then go on dividing here, right? So let me erase this and write down a format that can be written here for dividing the polynomials. So dividing or on dividing the dividend polynomial, that is always written as p of x, by the divisor polynomial, that is mostly written as g of x, we get a quotient polynomial, that is q of x, and a remainder polynomial, r of x. See friends, this remainder polynomial can be 0 sometimes, but dividend, divisor and quotient polynomials will never be 0. That means you can simply write where p of x, g of x and q of x are all non-zero, right? You can write where p of x, g of x and q of x are all non-zero. That means they will never be 0 or a constant polynomial, but remainder can or cannot be a 0 or a constant polynomial. So the writing down the format here, that is dividend polynomial is equals to divisor polynomial into quotient polynomial plus remainder polynomial, right? Dividend polynomial is equals to divisor polynomial plus quotient, divisor polynomial into quotient polynomial plus the remainder polynomial. That is the format of writing down the division of polynomials, right? In other words, I can also write it like p of is equals to g of x into q of x plus r of x, right? See friends, as I have written that dividend polynomial is p of x, divisor polynomial is g of x, quotient polynomial is q of x and the remainder polynomial is r of x. So p of x is equals to g of x into q of x plus r of x. That is how the remainder theorem goes here, right? But actually this is not the theorem, this is a statement that is proved by the division of polynomials. So that is about the division of polynomials. This statement is proved by the division of the polynomials. The remainder theorem actually goes afterwards. So we shall check it out how it goes, right? Okay. Now that example that is already written over here, let us check it by another method. So another method is, okay, I am erasing this one right now from this, right? Another method here, that is here g of x is equals to, what is there? This is the second method of finding the remainder. This was the first method. First method is to divide. Second method is quite an easier one, that is simply putting the values of the variables that we have discussed previously in the topics, right? Here g of x is equals to x plus 1, let g of x equals to 0. That means x plus 1 equals to 0 and hence x equals to -1, right? We got the value x equals to minus 1. Now this x equals to minus 1 is to be substituted in p of x. Now p of minus 1, that is 3 into minus 1 square plus minus 1 minus 1, right? Here 3 into minus 1 square, that is 3 into 1 minus 1 minus 1, minus 1 square plus 1, and plus minus minus 1, and again that is a minus 1. So we shall get here 3 into 1, that is 3, right? 3 into 1, that is 3, and minus 1 is minus 2, which is equals to again 1. You can check it out, friends, that the number, the remainder that we got by dividing these two polynomials is exactly equals to 1 in both the methods. So in method number 2 here, we shall take the polynomial, the divisor polynomial, the second polynomial, and from that we shall find out the value of variable x, and that value of variable x will now be substituted in the dividend polynomial, which gives me a value, a non-zero value, or sometimes it may be 0, and that is exactly the remainder of the polynomials, right? So in this way we can simply find out the remainder, or we can verify that what the remainder we shall get. Okay, so that is clear here. Okay, let me take one more example here. Divide 3x raised to 4 minus 4x cube minus 3x minus 1 by x minus 1. So friends, here we are having two polynomials, right? The first one is of degree 4 and the second one is of degree 1. Now one more thing let me add here is, whenever we are dividing a number, or whenever we are dividing two polynomials, at that time you must note that always degree of the dividend polynomial, right? Let me write down here clearly that whenever we divide two polynomials, whenever when we divide two polynomials, at that time the degree of divisor polynomial is always less than that of the dividend polynomial. So friends, this goes like degree of g of x is less than degree of p of x. You can also say that less than or equals to, because if it will be greater than, that means if the degree of the divisor polynomial is greater than the degree of the dividend polynomial, then that division is actually not possible, because in case of division of polynomials you cannot divide the smaller number by a bigger number, or a smaller polynomial by a bigger polynomial, right? So it goes like degree of g of x is always less than or equals to degree of p of x. Now let me take that example, that second example. Divide 3x raised to 4 minus 4x cube minus 3x minus 1 by x minus 1. So I got a note from this that the degree must always be less than or equals to the degree of the dividend polynomial is always greater than or equals to the divisor polynomial, or divisor is less than or equals to dividend polynomial. So we are going to divide. First of all, let us check that all the terms are being in the descending order of their powers of the variables or not. Here friends, in this dividend polynomial, if you see, there is a term missing with the variable x square. So here let me write down p of x is equals to 3x raised to 4 minus 4x cube plus 0x square minus 3x minus 1. Friends, whenever there is a term missing, you will always write this term as plus 0x square or 0x or 0x cube or 0x raised to 4. The thing behind that is, if the coefficient of that variable is 0, then that term is already 0, because 0 multiplied by x square is again 0, 0 multiplied by x is again 0, 0 multiplied by x cube is again 0. So that 0 is not physically present there, right? That means here x square, the term with the variable x square is not present, and hence we shall write it as 0x square, and there is no change in g of x, so g of x is equals to x minus 1. Okay friends, so that is about the polynomials p of x and g of x. Now let me first of all divide this and get the value of the remainder. Friends, this division here that we are going to perform is actually known as the long division. That is known as the long division. So x minus 1 is dividing the polynomial 3x raised to 4 minus 4x cube plus 0x square minus x minus 1. Okay, so this is how the division is written here. The division of two polynomials is written over here. Now let us go on dividing the first one. Friends, as I discussed, we are going to make the first term same. So the first term here in dividend is 3x raised to 4 divided by x. So if I cancel x, that gives me 3x cube. So we are going to multiply the divisor polynomial by 3x cube. So that is 3x cube. 3x cube into x, that is 3x raised to 4 plus 3x cube into minus 1, that is minus 3x cube. Now check what is the sign here, plus, so we shall put a minus over here. Check what is the sign here, minus, so we shall put a plus. This is how the subtraction for polynomials work. This is how the subtraction for the polynomials work. That means if the sign is minus, we shall make it plus, or if it is plus, then we shall make it minus. So we shall now look for the new signs that we have written over here. That is minus 3x raised to 4 plus 3x raised to 4 is cancelled, that is 0. And minus 4x cube plus 3x cube, that is minus 4 plus 3, that is minus x cube. Right? Friends, whenever you are going for addition or subtraction of polynomials like this 4x cube and 3x cube minus 4x cube plus 3x cube, you simply first of all subtract that numbers, that coefficients, and then write the variable as it is. So first of all check minus 4 plus 3. What is minus 4 plus 3? Minus 1. And simply what is the variable associated there? X cube. So that is minus 1 x cube, or simply minus x cube, plus this will be here plus 0x square. Right? Now again check, this is minus x cube, that is x. So if I divide minus x cube by x, and x will be cancelled, and that becomes minus x square. So the divisor is now multiplied by minus x square, that is minus x cube, minus into minus plus x square into 1, that is x square. So again change of sign, minus becomes plus and becomes minus. So that is minus x cube plus x cube, 0. We shall now look for the new signs. 0x square minus 1x square, that is again minus x square. This is to be brought down here, minus x Okay friends, now again we shall check minus x square to be divided by the divisor polynomial, that is x, so that becomes minus x. So we shall now multiply the divisor by minus x. Minus x into x, that is minus x square, minus minus plus x into 1, that is x. So again change of sign, minus becomes plus and plus becomes minus. Now we shall look for the new signs here. Minus x square plus x square, that becomes 0. Minus x, that is minus 2x, and this one is now brought here at the bottom. Okay, again for the last time, the term here in the dividend is minus 2x, the term in the divisor is x, and x is cancelled, that becomes minus 2. So we shall write down, or we shall multiply the whole divisor with minus 2. Minus 2 into x, that is minus 2x, minus 2 into minus 1, that is plus 2. Again change of sign, minus becomes plus and plus becomes minus. Minus 2x plus 2x is 0, minus 1 minus 2 is minus 3. So after performing this whole division, we came to a conclusion that the remainder when we divide this p of x by g of x is minus 3. Okay friends, so here we performed the long division and we found out that the remainder is minus 3, right? Now what if I find the remainder by another method? So this was the first method, right? For the second method, let me write down here itself at the bottom. Second method. Let g of x equals to 0. This implies x minus 1 equals to 0, which implies x equals to 1. Now we shall put x equals to 1 in the given polynomial p of x. Therefore, p of 1, that is equals to 3 into 1 raised to 4 minus 4 into 1 cube minus 3 into 1 minus 1. Rather than putting it here, we shall put in the question itself. So what is 1 raised to 4? That is 1. So 3 into 1 minus 4 into 1 minus 3 into 1 minus 1. Okay, so 3 into 1 is, that is equals to 3 minus 4 minus 3 minus 1. So you can simply cancel out. Okay, so I think we are not getting the required remainder here, that is minus 3. So I might have made some mistake somewhere, that is x minus 1 equals to 0 and hence x equals to 1. 1 raised to 4, 3 into 1 3 minus 3 into 1 is again minus 3. 3 cancel, minus 5 we are getting. So I think there might be some error here. 3 into x cube, sorry, 3x raised to 4 minus 3x cube, it becomes plus minus 4 plus 3, that is minus x cube. Let me check it here friends. 3x cube minus x square minus x minus 2 when multiplied by x minus 1, that is 3x raised to 4 minus 3x cube minus x cube. plus x square minus x square plus x minus 2x plus 2. So x square is cancelled, that is 3x is to 4 minus 4x cube minus x plus 2 minus 3, that goes for minus 1. So where did I make a mistake? That is good, I think. Division is true, but the thing that goes here is, okay, that is x minus 1 good, x minus 1 equals to x equals to 1. 3 into 1 3 minus 4 into 1 is 4 minus 3 into 1 is 3 minus 1. So 3 and minus 3 can be cancelled, it becomes 0, which is minus 5. So okay friends, let us don't do this right now. I think there might be some error here in this division. Let me check it and then I'll come back to you with the same question. Okay, now coming back to this remainder theorem, that whenever we found out that we got this division as minus 3 here, right? Okay, let it be. So that is about this division here right now, friends. Now we shall come to the next sum here with me. I'm having that here. That is divide the polynomial. I think this might be noted here. That's why I'm erasing this one also. Okay. Now find the remainder by dividing x cube plus 1. The third one. Find the remainder by dividing x cube plus 1 by x plus 1, right? So this is the question here. So what can you write down here? P of x is here, P of x is equals to x cube plus 1, but friends here some of the terms are missing. That means x cube plus 0x square plus 0x plus 1, right? And g of x, that is good, that is written again as x plus 1 only, right? So let me divide here. That is x plus 1 is dividing x cube plus 0x square plus 0x plus 1, right? So again we shall check for the first terms. That means x cube and x. If I divide x cube by x, that gives me x square. So that is x cube plus x square. Again change of signs, plus becomes minus. So that x cube and minus x cube is cancelled. This will become minus x square, because here it is 0. 0x square minus x square, that is minus x square. And this 0x is again brought down, so that becomes plus 0x. Is it clear, friends? So that is minus x square and x. Again you shall multiply it by x, sorry, minus x, that becomes minus x square minus x. Change of signs, both the minus becomes plus. So that goes for plus x square and plus x. Here the signs will be cancelled. Minus x square plus x square is 0, and here it becomes plus x. This one is brought down here at the bottom, so there is no need of multiplying anything here. That becomes x plus 1. both the signs will be changed, and hence you can see that the remainder here is 0, right? Note that, friends, when I got the division here, the remainder is 0. That means x cube plus 1 when divided by x plus 1 gives me a remainder 0. Okay, now this goes for the remainder 0. Now for the second method, let g of x equal to 0. This implies x plus 1 is 0, and this implies x equals to minus 1, right? We got x equals to minus 1. Finding out p of minus 1, that means simply putting this x equals to minus 1 here. So that is minus 1 cube plus 1. We shall put it here rather than putting it in the second one. So minus 1 cube is minus 1 plus 1, which is again 0. So you can check out, friends, that we got 0 here. To confirm it with that one, we are having the remainders in both the methods. That means the second method and the first method, we are having the remainders in both the methods as 0. In the previous example, we might have made some mistake over there. I'll confirm it with the question again and I shall come back to you, right? So this, we got 0 as remainder in both the methods. That was the first one, the long division method. We got it 0 here. Second one, we got it 0 here by simply putting the values. Coming to an important conclusion here, right? Coming to an important conclusion here. After this example, after solving these three examples, I'm coming back to a conclusion that whenever the divisor polynomial is a linear polynomial, when the divisor polynomial is a linear polynomial, find the zero of that divisor polynomial and replace it in the dividend polynomial, which gives us the remainder of the division of polynomials. When the divisor is a linear polynomial, friends, note that I am talking about only a linear polynomial. Whenever the divisor is a linear polynomial, at that time only find the zero of that divisor polynomial. How you are going to find out the zero? The zero is being found out by simply letting it to 0. So find out the zero of the divisor polynomial and replace it in the dividend polynomial, which gives us the remainder polynomial of the division of polynomials. Now this I have written in my own words. Now the theorem that we are having here, the remainder theorem, the statement of the remainder theorem, that goes like, here I am going to write down the statement of the remainder theorem. That let p of x be any polynomial, let p of x be any polynomial of degree greater than or equal to 1. That means degree of p of x must be greater than or equal to 1, right? Degree of x must be greater than or equal to 1. This is the condition. And let and let a be any real number. What is a? Any real number. Let a be any real number. So this is the conditions. That means the first thing that we must have, that let p of x be any polynomial of degree greater than or equal to 1, and let a be any real number. So this both the things must be present over here. Now if p of x is divided by the linear polynomial x minus a, if p of x, what is this p of x? The polynomial that we took. If p of x is divided by the linear polynomial x minus a, then p of a is or gives the remainder, then p of a gives the remainder of the polynomial. Is it clear? Now friends, as we talked about here in the first, or in the statement I have written over here, that when the divisor polynomial is a linear polynomial. So here in the statement that I have written over here, that linear polynomial is x minus a, that we are talking about here, x minus a. So let p of x be any polynomial of degree greater than or equal to 1, and let a be any real number. If p of x is divided by the linear polynomial x minus a, so we can say that now the divisor is x minus a and dividend is p of x, right? Divisor is x minus a and dividend is p of x. So if I divide this dividend by the 0 of the divisor polynomial, 0 of the divisor polynomial, that means x equals to a, 0. How can we find out 0? Simply take this equals to 0. That gives me x equals to a. If I replace all the x, by a in this p of x, then what shall I get? P of a. That is the thing that we are talking here. Yes or no? This p of a, that simply means replacing all the x in p of x by the a. And what is a? A is a real number that we obtained from the divisor polynomial. Yes or no, friends? Okay, so that is the thing that we are having here. So again, when the divisor polynomial is a linear polynomial, find the 0 of that divisor polynomial and replace it in the dividend polynomial, which gives the remainder of the division of the polynomials. And the statement, the actual statement of the remainder theorem, that goes like, when p of x, or let p of x be any polynomial of degree greater than or equal to 1, and let a be any real number. So if p of x is divided by the linear polynomial x minus a, then p of a will give us the remainder of the polynomials, or p of a is the remainder of the polynomials. Is it clear, friends? So that is how the remainder theorem works. Now let me solve some examples here with you, so that you can clearly understand that how is this remainder theorem working and what is actually the remainder theorem. Is it clear? So you just need to understand this statement here, friends. There is no need to learn by heart, because the statements are not being asked in the examinations, right? So you just need to understand it. Now I'm having some questions here with me. Let me solve it. I'm continuing with the numbers. The fourth one, I'm having a p of x, that is x cube plus 3x square plus 3x plus 1, and I'm having a g of x also, that is x plus 1. And for the same question, p of x is equals to same as that I have written here, and g of x is now changed to x minus 1 by 2. I need to find out the remainders in both the sums, right? In the fourth one and the fifth one. Now, what you are going to do, friends, here is you are going to perform the long division by yourself. Okay? And I am going to do it with the remainder theorem. Or should I perform the long division here? Friends, try the long division by yourself so that you can come to know that what or how actually that works. If you are facing any problem, then we shall solve it in the class lecture that we are going to conduct and the next sessions, right? Let me do it here by the remainder theorem so that we can practice it here itself. So, self-study or homework is the long division, right? The long division you are going to perform it by yourself. So here, sorry, let me change the pen. Here the solution goes like, let or here g of x is equals to x plus 1, letting g of x equal to 0. So if I take this g of x equal to 0, then at that time what can I say? That x plus 1 is equals to 0, or simply it means x equals to minus 1. So we had, again you can see here that this p of x, whatever the polynomial here, is having a degree greater than 1. It is divided by a linear polynomial x plus 1, so that is again compared with this x minus a, the polynomial that is written here. Now p of a is the remainder, p of a, that means first of all we need to find out x equals to a or that a. Now p of minus 1, that is minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1, right? So this is how it goes. And what is minus 1 cube? Minus 1 plus 3 into minus 1 square, that is plus 1. 3 into minus 1 is 3 and 1. So that is again minus 1 plus 3 minus 3 plus 1. Minus 1 plus 1 cancel. Minus 3 plus 3 cancel. And hence the remainder or the value is 0. Hence the remainder is also 0. So the remainder of this division is 0. Is it clear, friends, that the remainder of this division is 0? Let me solve it for the next one. This will be somewhat complicated. Here g of x is equals to x minus 1 by 2. Therefore, let g of x equal to 0. Therefore, x minus 1 by 2 equal to 0. And hence x equals to 1 by 2. So we got the value of x, that is 1 upon 2. Now, first of all, note this down, friends, so that I can move on to there, because I'll need some space over there. Okay, so let me continue it here. That is, we got x equals to 1 upon 2. Therefore, p of 1 upon 2, that was, sorry, I got the question also erased, x cube, that is 1 upon 2 cube plus 3 into 1 upon 2 square plus 3 into 1 upon 2 plus 1. right? So I have replaced the values here, that is x by 1 by 2. So that is 1 upon 2 cube, which is equals to 1 upon 8. 1 upon 2 cube simply means 1 by 2 into 1 by 2 into 1 by 2. So that is 1 into 1 into 1, that is 1. 2 into 2, 4. 4 into 2, 8. In this way it works like for the division of sorry friends. In this way it works for the multiplication. 3 into 1 upon 2 whole cube, that is 1 upon 8, plus 3 into 1 upon 2 square, that is 1 upon 4, plus 3 into 1 by 2, that is 3 by 2, plus 1, right? So that is equals to 1 upon 8 plus 3 into 1 by 4, 3 by 4, plus 3 by 2 plus 1. So let us take the LCM here. The LCM here would be 8. So to make the common LCM 8, the first term will be kept as it is because there is a denominator 8. Second term 3 by 4 is to be multiplied by 2 in both numerator and denominator. So that becomes 3 into 2, 6, plus the third term 3 by 2 should be multiplied by 4 so as to make denominator 8. So in numerator we shall multiply by 4, that becomes 12, and the last one will be multiplied by 8. So that becomes, I think, 12 plus 8, 20, plus 7, 27, and hence the remainder here is 27 upon 8. Okay friends, so the remainder of this division, if we perform it by the long division method, will give us the remainder 27 upon 8. Okay, so that is how the long division works. Okay, so now we are going to solve some more sums of this kind, the remainder theorem. 2 or 3 I am having it here with me, then we shall move on to the next topic. Okay, so the next sum I am having right now here with me is, so we continue with the fourth and the fifth one. Now let us solve the sixth one. P of x is equals to x cube minus 6a square, sorry, ax square, my mistake, minus plus 6x minus a divided by x minus a. The seventh one that I am solving here is p of x is equals to x raised to 4 plus x cube minus 2x square plus x plus 1 divided by x minus 1, and eighth one, p of t is equals to 4t cube plus 4t square minus t minus 1 divided by g of t is equals to 2t plus 1. Right, we need to find out the remainders in each of these three cases that we are having by the use of the remainder theorem. Okay, so friends, today, sorry, not today, now here g of x is equals to x minus a. Let 0, therefore x minus a is equals to 0, and hence x is equals to a. Right, we got the value of x, that is equals to a. Now finding out p of a. P of a, that is a cube minus a into a square plus 6 into minus a. Right, so what is a whole cube? That is a cube minus a into a square, that is again a cube plus 6 into a, that is 6a minus a. So a cube and minus a cube will be cancelled. 6a minus a, which is equals to 5a. So the remainder, therefore the remainder is 5a. Right, the remainder is 5a. Now moving on to the seventh one, that here g of x is equals to x minus 1. Therefore let g of x equals to 0, therefore x minus 1 equal to 0, and hence x equals to 1. Right, now we shall find out p of 1. So finding out p of 1, that is 1 raised to 4 plus 1 cube minus 2 into 1 square plus 1 plus 1. Right, I am writing that step here in the second line. So that is 1 raised to 4 is 1 plus 1 cube is 1 minus 2 into 1 square. 1 square is 1, that is 2 into 1 2 plus 1 plus 1. So that is 1 plus 1 2, 2 minus 2 is 0, and the remaining thing is 2. So we got the remainder, therefore the remainder is 2. Right, so we got the remainder in both the cases. The third one, here g of t is equals to 2t plus 1. Therefore let g of t equals to 0, therefore 2t plus 1 equals to 0, and hence t is equals to minus 1 by 2. Right, now finding out p of minus 1 by 2, that is 4 into minus 1 by 2 cube plus 4 into minus 1 by 2 square minus minus 1 by 2 minus 1. Right, so that is equals to 4 into minus 1 by 8 plus 4 into 1 by 4 minus minus plus 1 by 2. This minus minus will become plus 1 by 2, and that is minus 1. So you can cancel out this 4 and 8 by 2, this 4 and 4 by 1, that becomes minus 1 by 2 plus 1 plus 1 by 2 minus 1. Minus 1 plus 1 cancel, minus 1 by 2 plus 1 by 2 cancel, and hence p of minus 1 by 2 is equals to 0. Therefore the remainder is 0. Right, the remainder of this, or the remainder of this division, the remainder of the given polynomials is 0. Okay friends, so this is how you can find out the remainder using the remainder theorem. Let us again see what the remainder theorem is. What the remainder theorem is: let p of x be any polynomial of degree greater than or equal to 1. Right, that means the dividend polynomial that we are having will be having a degree, or must have a degree greater than or equal to 1, and let a be any real number. Let a be any real number. Now if p of x is divided by the linear polynomial x minus a, that means if the dividend polynomial p of x is divided by the linear polynomial so formed x minus a, then p of a will be the remainder of the polynomial, or p of a is the remainder of the polynomials. Is it clear? So that's it about the remainder theorem. So today's topic, that was the remainder theorem.